You know, this is the last lesson of the year, at least for this year, or one of my last ones, depending on when you're watching this. I don't know. I'm getting a little edgy. I'm going to get edgy on this joke, okay, guys? I got a joke for you. It's coming. It's edgy. It's a religious joke. How does Moses make coffee? He brews. Get it? He brews because like he brews the coffee in the Hebrew. I didn't say it was a good joke. Hope it wasn't offensive. I don't think it was offensive. But anyways, we're going to talk about Bronsted-Lowry acids and bases today. We're going to talk about a different type of definition of an acid and base and how to identify them and do some little stuff with them here. So let's get rolling, shall we? All right. Defining some acids and bases. So far, what we've been talking about is the Arrhenius model. And this shouldn't be anything different if you've watched and you've been in class and you've taken a look at the other definitions of what acids and bases are. You'd see the Arrhenius model. The Arrhenius model states that an acid is a substance that produces hydrogen ions in an aqueous solution. That's what we said already. The definition I already gave you was the Arrhenius model. And if you've had other teachers talk about acids and bases that wasn't really advanced in chemistry, they were giving you the Arrhenius model because they probably also told you that a base is something that produces the hydroxide ions in an aqueous solution. So an example of an acid would be, let's just take a look at the first one. If we take a look at the first one here, by the definition, if hydrogen ion is produced, that makes it an acid. So what you're looking for is if this is producing hydrogen ion, this makes that an acid. So this is hydrochloric acid. And in the second one, if you notice that a hydroxide ion is produced, the fact that hydroxide was produced makes this a base. The Arrhenius model. And I have to give credit to Logan, one of my students. Noted that of the Arrhenius family, Arrhenius was the genius. I don't know why I repeated that. Okay, let's talk now about the Bronsted-Lowry model. The Bronsted-Lowry model, it starts off very much similar to the Arrhenius model in that an acid is a substance that donates hydrogen ions. Okay, that's the same definition. It's a substance that donates hydrogen ions. That makes it an acid. So it's not changing anything. But if you notice the definition of a base with the Bronsted-Lowry model, a base is a substance that accepts a hydrogen ion. There's no mention of hydroxide here. A base is a substance that accepts a hydrogen ion. So in the Bronsted-Lowry model, you do not have any mention of hydroxide. It's not necessary. So if you take a look at this reaction here of an acid, so X could be any acid, so it could be hydrochloric acid or nitric acid or whatever, HX, it's some sort of an acid. And it's reacting with water. You put the acid in water, it will produce hydronium, and whatever that anion was will be produced. So based on this definition here, the HX would be the acid because it is the substance that's donating the hydrogen ion. You got to look over here at what's gaining the hydrogen ion. Well, you can see that the water gained it. So what donated it was the HX, gave the hydrogen ion over here. So the hydrogen ion went to the water. That's what's going on here. Hydrogen goes to the water, producing this. The base is a substance that accepts the hydrogen ion. So since water accepted that hydrogen ion and became this, then water would be the base. So notice there's no hydroxide in here, but this is an acid-base reaction, that the acid is what donated to the base. So you just take a look at which one gave the hydrogen ion and which one received the hydrogen ion to figure out which one's the acid and the base. The Bronsted-Lowry model goes a little bit further to talk about the products. And when we talk about the products, we're going to talk about the conjugate of these acids and bases. So the conjugate acid is the species produced when a base accepts a hydrogen ion. So the base will turn into the conjugate acid. And by the same type of definition, the conjugate base is a species that results when an acid donates a hydrogen ion to a base. So the conjugate base is the result of the acid, what happens to the acid after it loses its hydrogen ion. So the conjugate base is the species that results when the acid loses its hydrogen. So the conjugate acid is what happened to the base once it gained one. The conjugate base is what happened to the acid after it lost one. So let's go back to that equation that we were just looking at. With this definition here, can you figure out which one will be the conjugate acid and the conjugate base? Well, if you take a look here, the conjugate acid is what happened to the base. When the base gains a hydrogen ion, it becomes a conjugate acid. So you see this base here, gains a hydrogen ion, becomes the conjugate acid. And the conjugate base is what happened to the acid after it lost the hydrogen ion. So if you take a hydrogen ion away from HX, all you have is X negative. So these are your acid base pairs. So the acid becomes the base and the base becomes an acid. If you were to flip this equation, if you were to flip it the other way around, what's on the left is always the acid and base. What's on the right or product is always the conjugate acid and the conjugate base. So if it was the other way around, then this would be your acid and this would be your base, and your acid would become the conjugate base, and your conjugate base would become, and your base would become a conjugate acid. That's if the equation was flipped around. It would be, regardless, this is always going to be the acid and this one's always going to be the acid. And that's how you look at your base pairs. So let's do a little more practice with this. Remember, the acid is the substance that loses the hydrogen ion. So what's losing the hydrogen ion here? Okay, we've got hydrogens in both of them. We take a look here. Which one lost it? It looks like water lost it and gave it to the ammonia, right? Therefore, water is the acid. Water gave a hydrogen ion to the ammonia. And water then, after it gave it to the ammonia, what does water become? It lost a hydrogen ion. It becomes hydroxide. So the acid became the conjugate base, and ammonia is what accepted the hydrogen ion. So that's your base, and then what it becomes is the acid, the conjugate acid. So the base becomes a conjugate acid. In number 2, let's take a look here. Okay, we've got cyanide and hydronium becoming water and hydrogen cyanide. So if we take a look at this here, which one is losing a hydrogen ion? Again, if we take a look here, we see the hydronium is losing the hydrogen ion and it's becoming water. So it's H3O positive and now it's becoming H2O liquid. So it lost the hydrogen ion and it gave that hydrogen ion to the cyanide. And so the cyanide is the base because it accepted that. And what did the cyanide become? It became hydrogen cyanide. So that's the conjugate base. Okay. So that's what you should think about when you're doing these things. My advice. Here's some more practice. Why don't you pause the video and see how you do with these things. And then after you pause the video, I will work these ones out too. So let's try that. So hopefully you did that. And now you've unpaused. Let's take a look at the answers.